Hi, I'm John Grundy, and I'm going to talk to you about our work on improving human-centric software defect evaluation, reporting, and fixing. It's work done with myself, some of my students, and my colleague, Arno. First of all, I'll talk about the motivation for our work, talk about key research questions that we have in this work, the approach we took, personas and prototype we developed, some usage examples, evaluation of the work, key future work. Software has defects when released, just can't be avoided. End users need ways to report defects to developers. Unfortunately, our current defect reporting tools and mechanisms are just too limited for many of the kinds of defects that we encounter and for the kinds of users that use the software. An example of this is Bugzilla on the right. This is reporting a usability defect, but there's a number of problems that we found in previous work that we did analyzing these existing reporting interfaces for these kinds of human-centric defects. They're often either too complex, asking too much information from users, or actually too simple and they don't capture the kind of information that we really need. They lack guidance for users. So often it's just a text field where you put most of the information, and in reality, users need a lot of guidance as to the kind of information that developers would find helpful in fixing the defects. Many of them lack support for diverse end users, so users with sight challenges, hearing challenges, control of interfaces, and so on. They lack some sort of indication of the importance to the users of the defect, how much it affects them in carrying out what they need to do with the software interface. And often developers have a lot of trouble in understanding the defects, understanding what is the problem, why is it a problem, and then diagnosing and fixing it. Human-centric defects themselves, defects relating to the diverse human characteristics of the users, are both hard to report and hard for developers to understand. We need a better way of both supporting diverse end users and reporting the defects that they have and helping developers to address these. Previous work, we developed a wizard-based interface to do this for usability defects, created a new taxonomy of these defects that helped both users capture more important information about them and to classify them for developers. Rich information was captured through a wizard-based interface, as you can see illustrated on the right. Provide an easier to use, more user-centric reporting interface, but in that work we only focused on usability defects and didn't support differently abled users, somewhat ironically. So some of the interfaces we developed were not really very effective for diverse end users from a usability point of view, as well as reporting defects that they encounter, depending on those challenges that they have. In this work that I'm talking about today, we focused on better supporting diverse end users to report issues. We wanted to ask the questions, can we improve defect reporting for people with diverse usability issues? Can we improve the defect reporting for people who are visually impaired, hearing impaired, or have issues in reading text on an interface or icons on an interface? Wanted to improve the defect reporting for people who have trouble physically interacting with the interface, the application. We also wanted to ask questions about, can developers be assisted in diagnosing and fixing such defects? So does educating users about them improve the developer's understanding of the defect? Does capturing frequency about how often the defect causes problems for the user help the developers in perceiving the correct level of severity of the defect? And does giving more information on the defect reporting forms help the developer in terms of understanding, diagnosing, and fixing the defect? The approach we took is to develop a set of personas for end users and developers to characterize a range of different people that would both be involved in using software, reporting defects, and fixing defects. Designed a set of reporting interfaces to support the capture of these defects. We designed some extensions or modifications to support a range of users with diverse challenges in using the defect reporting tools. We designed ways to present this information to developers, built prototypes of these tools, and did cognitive walkthroughs to evaluate them, simulating each end user persona and each developer persona receiving the defect. We then use these cognitive walkthroughs to feedback and refine our designs based on our findings. So one of the key parts of this work was to develop personas to represent different users and developers. And the idea of this was to anonymously report defects to developers using a persona in place of information about the real user or real user characteristics. That way we could represent a number of challenges that end users have in terms of their human issues, and developers could then be presented with that information along with the defect report. The idea was then that developers could use the defect report and the personas of the users to help them better understand the context of use, the issues the user was having with the software, help them doing testing of any fixes that they've come up with or design improvements to address those human-centric issues, and potentially to feedback to the users as well. We developed some developer personas to help us better understand the range of different developers that might be involved in receiving human-centric defect reports, diagnosing faults and fixing faults. So we want to see what the impact of different developer personas might be on diagnosing the defects found, identifying ways that different kinds of developers might try and fix a defect, particularly when they had quite different issues or challenges to the end users reporting the defect. And we also wanted to use the personas to help in testing the defect being fixed. One other use of developer personas we didn't really explore in this work, but would be very interesting in future work, is to help perhaps triage the human-centric defects and direct them to particular developers that might share or at least might better understand some of the user challenges of the users reporting the defect. And we might try different ways of explaining the same human-centric defect report to different developers with different characteristics themselves. In the end, we developed 5 personas representing colorblind users, those with dyslexia and aphasia, hearing impaired, mobility or dexterity impaired, those who heavily use screen readers. And we did a cognitive walkthrough with these personas of several existing apps to try and generate a number of human-centric defects relating to using these apps from those diverse user perspectives. Those included Skype, Moodle, Snapchat, and Grab to give a bit of variation. Here's a couple of examples of personas and some of the results of cognitive walkthroughs. On the left is Michael, a developer or junior developer, has dyslexia and aphasia, and wants to use a bug tracking tool, but has challenges with icons. Some are not self-explanatory. Writing a description of a bug, so when doing reporting, is challenging. Wants to have some spoken text to help understand sentences better, and so on. On the right is Roger, who's a user, and in this case it's a mature age student trying to use an interface, has some mobility and dexterity issues, and some of the issues encountered with existing websites included difficulty in traversing complex pages, difficulty in adjusting the content, so using the controls of the web browser or the laptop computer or the mobile device doesn't help address some of these issues. Hard to complete some of the tasks because there's not alternative ways of interacting with the interface, and difficulty interacting with some of the functionality it requires, for example, clicking on a very small button or manipulating very small amounts of information on the interface. Once we've done these persona developments, cognitive walkthroughs, identified a number of defect reports of existing interfaces, we developed 2 prototypes to allow defect reporting and then defect reading. So we developed a mobile and web interface for our defect reporting tool prototype. This was used by the different personas to enter the appropriate defect reports, for example, as shown on the previous slide. And then we had a web application for developers that presented these defect reports to them for them to use. We also developed some configuration support for these interfaces to try and better support both end users and developers with various challenges. So again, those use screen readers, variations of font size, font type, color settings, and so on, supporting voice input, supporting dark mode, large buttons, etc. And the idea of this was to, again, make sure that a wide range of both end users and developers could access the defect reporting tools in ways that weren't well supported by current systems. I'll give you a usage example now. Here I am reporting a bug from my interface. So typically I start off with a short description of that bug, which is used to index and organize these in a defect reporting queue. I then might be asked for additional information that might include information about the data I was entering or I wanted displayed, my interactions, could include screenshots, videos, etc. There might be information that's useful to the developers around how often the user makes use of this application, how often they encounter the issue, and we wanted to try and use this to better understand the frequency of impact of these defects on end users. We also want to support, as I mentioned before, a number of challenges that end users and developers have in using existing defect reporting tools. To this end, we provide a range of adaptive controls, zooming, contrast, rotation, different fonts, different mechanisms for carrying out the defect reporting task itself, voice input, etc. Here's an example where I can either type in text or I can use voice input to give feedback about a particular defect. Here's an example of the dark mode where I get a much greater contrast between the text. Here's an example of some expanding of some of the text in the interface. Note, because it's an app level control, we can do much more finer grained control of the interface than any browser-based controls or system-based controls. Here's an example of a desktop prototype, again with a range of controls provided to allow the user to tailor the interface to their needs. We ideally wanted to evaluate our prototype with real end users, both developers and defect reporters. Unfortunately, COVID-19 meant we had a lot of challenges in recruiting people to carry out our evaluations and doing the evaluations themselves. In the end, we used classmates of the student team to carry out cognitive walkthroughs with the personas and to mimic the challenges that these different users would have in using the interface with a combination of overlays, modifying color and font changes to simulate interface challenges and so on. And we also used user personas that student team members walk through each of these from a developer perspective to try and both interact with the defect reporting interface to read reported defects and to try and understand and action them. Just summarizing some of the key findings, there's more details in the paper itself. In terms of our first question, the visual and hearing and interface interaction challenge users, we found that we had some good support for some of the user needs in this regard, but our screen reader support still needs further work. Those who would heavily make use of a screen reader would still have difficulty in interacting and using the interface. We improved the interface support for people that had interaction issues in terms of fine motor control and so on, but there's still improvements that need to be made around better navigational support, using of shortcuts, avoiding scrolling, screen orientation change as needed, etc. We wondered if educating users about defect reporting would help in giving them a guided defect report, as done in our previous work with the system. We did find that this was good and helped provide much richer information about defects, and that providing the persona of the reporter did assist the developers in understanding the context of use, the challenges that the different end users were having with the same interface. It was unclear if frequency of use or capturing this was actually helpful to both diagnosing defects and understanding their severity. Further work needs to be done on that. The level of complexity of the form, again, there's some unclear results around balancing the amount of detail and overburdening the reporters versus capturing enough information for different kinds of human-centric defects. for developers to be able to understand them, find them, repeat them, diagnose them, and then go about fixing them. So in summary, the work was found to be highly useful in terms of improving defect reporting for diverse human users, but a number of further challenges and research needs to be done to continue making improvements. Ultimately, we need a real end-user evaluation. Again, we didn't have ready access to the end users that we needed. Some of the classmates turned out to have some challenges, for example, color blindness and different cognitive styles, but we need a more diverse range of personas, a more diverse range of applications to try out our defect reporting forms on, and a more diverse range of developers as well. Some personas need much more information about them in order for developers to understand the challenges that diverse end users have than others, particularly those that developers are not familiar with or where they don't have those challenges themselves. What we captured, particularly accessibility related human issues in our personas in this work. There are many other human issues that people have that may influence their defect reporting: age, gender, culture, educational attainment, language proficiency, personality, cognitive style, and many more. We'd like to incorporate some or more of these in our personas and see if they have an influence on reporting defects and interpreting and fixing defects. We need to evaluate, again, our work on other application domains and to see if our defect reporting approach works as well for those as it did on the ones used in this work. Again, it's unclear for some defects how much information is needed compared to others, and for some user personas, what information that they need to report for those defects may vary compared to others. At the moment, it's unclear how well developers actually use the personas when we provide them with the defects, and we want to study this further in future work as well. So in summary, current defect reporting tools are not human-centric. And ironically, they're difficult to use for end users in terms of giving feedback to developers. We need to support a variety of end user challenges, if you like, human-centric characteristics in reporting defects. They need to be more human-centric, the defect reporting tools, which will improve uptake and improve quality of defect reports back to developers and ultimately improve software quality. And we want to further use developer personas, richer end user personas, and help us understand more deeply how human-centric defect reporting tools impacts overall software quality. Thank you very much for listening.